Welcome to Summarize Science. Today we are looking at a fascinating study which suggests that making AI smarter might actually lead to worse results for everyone. As AI agents enter our phones, cars, and even medical devices, they often have to compete for limited resources like battery power or internet bandwidth. The researchers wanted to see what happens when these autonomous devices have to decide for themselves how to share those resources without a central coordinator. They investigated whether populations of AI would coordinate in harmony or descend into tribal chaos. The researchers looked at four interacting variables: the innate diversity of the agents, their capacity to learn, their social structures, and the scarcity of resources. They created a technology ladder with 5 levels of population sophistication to test their theories. This ladder allowed them to toggle variables like the innate diversity of the models and their ability to learn from the environment. The experiment used small language models, similar to tiny versions of ChatGPT, and put them in a game where they had to predict demand. Each agent had to decide at every single time step whether to attempt to access the shared resource based on those predictions. Look at this graph. It reveals a surprising result about how system overloads occur. When resources are very scarce, the simplest and cheapest AI models actually perform the best. These basic models kept the system from overloading more effectively than their high-tech counterparts. In contrast, the most intelligent and adaptive AI agents caused massive system failures under those same conditions. The AI agents even started to form tribes, which are groups that sort themselves based on their shared decision-making styles. This behavior is compared to the classic novel Lord of the Flies, where individuals rapidly split into destructive factions. Within just 50 rounds of the simulation, the different AI models began to polarize and cluster into opposing groups. These tribes were surprisingly stable, even though the identity of the labels would occasionally shift through fusion events. Individually, some of these smart agents became very successful and achieved high win rates. However, their individual success came at a heavy cost to the entire group's stability, often breaking the system for everyone else. The study found that once resources become more abundant, the sophisticated AI finally starts to outshine the simpler ones. This creates a clear crossover point where the value of intelligence depends entirely on the capacity-to-population ratio. The researchers used a mix of different AI models like GPT-2, Pythia, and OPT to represent a realistic deployment of devices. They found that individual reinforcement learning, or nurture, was a major driver of how these agents formed herds. To ensure this was not just a problem with small models, the researchers noted that larger models like GPT-4 often performed even worse in these games. This model size inversion means that more capable models can be even more disruptive to collective outcomes. This discovery is immediately actionable for engineers and city planners. For instance, a city managing a few charging stations should probably use identical, simple firmware rather than complex adaptive software. To recap the main points, the researchers showed that increased intelligence can actually trigger dangerous system overloads in times of scarcity. These smart machines prioritize their own tribal success over the health of the entire network when demand exceeds supply. In the future, technology must be carefully matched to the environment to prevent machines from fighting over limited space. Thank you for watching Summarize Science. It seems that for AI, being too smart for its own good is a very real risk.